Hello. For today's math lesson, we are going to be doing these things. We're going to review factoring with the zero product property, and then we're going to locate and sketch quadratics and interpret the roots of a graph. Here's the first part of your classwork. You are factoring, solving for x in these 6 problems. And then for the later part, for questions 2 and 3, you are graphing these. Next up, you have this page where for each of these 6 quadratic functions, we're going to find the axes of symmetries and the coordinates of the vertex. We're also going to state whether or not that's a minimum or a maximum. Lastly, we have 3 practice problems. When given a graph, can we estimate where the roots are? I'll begin my review now. There's no enriched portion today. So for the first problem, we notice that I messed up the variables, so I gotta go fix it. All these should say y. Let me go back and change that. Y. Otherwise you can't solve it. The variables have to be the same. My mistake. Actually, those ones could stay. Okay. So for this first problem, it looks like this. I'll move things over. So here I subtracted 7y and I subtracted 18. I get this problem. It looks like I can factor this, so I can draw the box and the diamond. You can do so. I'll take a shortcut this time around, because I see that if I add 9 and add 2, I get to negative 18, and those two factors add up to negative 7. So y equals positive 9 or negative 2. For 1b, let's solve this. We have to add 12 to both sides. It helps to write them in decreasing order. Maybe this time I'll draw the box and the diamond. X squared. Middle term goes here. Two numbers that add to 35 but multiply to 7 and 5. So plus 7, x plus 5. So we get this thing in factored form equals 0. So x has to equal negative 7 or negative 5. So I'm adding in a couple more directions as I forgot to do that. Here's 2a and 2b. We can set y equal to 0, so this becomes factorable. I think for this particular problem, negative. Becomes a bit harder. So when I look at this, I don't think we can factor it easily. because when you think about all the factors that multiply to 5, none of those would get you to 2x, because it's just 5 and 1. Can't do much there. I think for this problem too, 6, 2, 3, 1, yeah, we can't. So for these two problems, what ends up happening is we can't solve, right? Not factorable, but we can estimate its solutions. Same thing here, not factorable, but we can estimate solutions. So let's try drawing a table. -2, -1, like that. There's 4 plus 8, 5, -4. -9, -1 plus 2 plus 5, 6. This one's just 5. -1 minus 2 plus 5 gets us to 3. Here, -4 minus 4 plus 5 equals -3. So somewhere in here, here's an answer. So one solution is between 1 and 2. And I think that's all we can do there. And we'll come back to this. We'll come back to this. We can try to at least start, make a table. This is more like guess and check. We'll try some numbers. -4 plus 12 minus 6. -1 plus 6 minus 6. -6. -1 minus 6 minus 6. -4 minus 12 minus 6. +2. -1. 6. -13. -22. So for this problem, it looks like we have between 1 and 2. Here's an answer. -2 and -1. And then we'll come back here. So the second part, when we start graphing, we'll see some more insights. 3a and 3b. For these problems, I think they end up being, no, they also end up being not no, they are factorable. One and not. Three and 3. Yeah, so for this one, from me listing out the factors, I can see that this one's probably not going to be factorable. This one is. So we'll come back to this one. And now we will try to graph this one over here, or factor it. Draw our box, draw our diamond, x squared, 5x squared, negative 6x, negative 5x, negative 1x. So negative 5 minus 1 equals 0. X has to be 5 or positive 1. Okay. So then we're going back. Now we're sketching these 4 problems, 2a, 2b, 3a, and 3b. So our initial guess in estimating these roots, or these x-intercepts, that's what we do when we factor something and solve for x. We think that based on the patterns, our graph here probably looks like this. Between 3 and negative 3 for the y-coordinate, 1, 2, 3, that, positive 9, 6, 3, shoot, messed up. Let me draw this bigger. Let's switch colors. So in red, alright, so way up here, it's going to be 9. Here, let's call this one 6. Here's 5. It goes to 3. One goes to 3. And 2, it goes, well, I think I made my arithmetic error. Negative. Yeah, no, that's right. So here it goes down to negative 3. Doesn't look right though. I skipped so many values. Oh, it's a 2. Okay. My graph is totally weird right now. So instead, we can start to go to the main point, right, for the vertex, right? Helpful formula for this is x-coordinate is located at negative b over 2a. To get y-coordinate, solve for the y value by putting x-coordinate into original equation. Right, so there's some notes. So for this problem, a is -1. This thing is b. If we needed c, it would be this value, but in this case we don't. b equals -2. So negative b over 2a becomes, let's move that down here, -2 over 2 times -1 equals 1. Then you go back to your original equation, negative 1 squared minus 2 times -1 plus 5, which equals -1 plus 2 plus 5 equals 6. Vertex is at -1, 6. So for our graph, why do I think this graph is like so off? It opens downwards, but my plot doesn't show that. Let's try this once more. Let's be more precise. So here are my x and y axes. Okay. So for our vertex, -1, 6. -1's here. 1, 2, 3, 4, 5, 6. This one's our vertex. I think that was my mistake. Zero is 5. I think my arithmetic here went wrong. This one should be 213. Oh, that's right. -2 is 9. Why does that pop up way over there? Okay, for sure it's going to open downwards. The shape should look like this. Somehow my table doesn't match that. Because for +1, well, that part matches up, +1. And for +2, it goes down to -3. Yeah, this side matches up. Like that. But these other ones, something's wrong with this side. -2 squared is 4, minus 4, 2 minus, I don't know. I'll have to come back to this. So we caught something went wrong here. For 2b, we'll go through that similar process. Our goal is to graph these, and because they're not factorable, we have to use the vertex to help us out. And our table from this part helps us figure out where to expect the x-intercept to be. So solving for the vertex, we'll use this neat formula. That's what also the axes of symmetry is. A is equal to -1, B is equal to -6, 6 over 2 times -1, -3. So our x-coordinate, -3 squared minus 6 times -3 minus 6, -9 plus 18 minus 6 gives us +3. Vertex is at 3, +3. That makes sense. Looks like it. It matches up with what we have this time on our table. So this one opens downwards, 1, 2, 3, like this. So this side, it keeps getting more negative. It crosses the x-axis somewhere here, between, like that. Opens downwards like this, and then it has to be symmetric. So there's your other half. And so that's what I mean by sketch. Using the vertex, finding the axis symmetry is super helpful. These are a bit time consuming. In your classwork, I think I only give like a couple sketch your graph for the enrich section, and it's for this reason. 3b, it's easier because we know where the x-intercepts are. We can figure out the vertex. So here's -6 over 2 times 1. 6 over 2 gets us 3. 3 squared minus 6 times 3 plus 5. 9 minus 18 plus 5. 9 minus 13 gives us -4. Vertex is at 3, -4. So now we know that our intercepts are at 1, 3, 4, 5, here, here, 3, -4, okay, there. Now we can draw our parabola like that. Three points make a parabola. And for this problem, the most we can figure out the vertex, and then we'll try to sketch out some other things. So vertex, -b over 2a, b is equal to -8, a is equal to 1. -8 all over 2. 8 over 2 gives us 4. 4 squared minus 8 times 4 plus 9. 16 minus 32 plus 9 gives us -16 plus 9, -7. Vertex is at 4, -7. 4, -7. This one opens upwards. It looks something like this. You know it's going to have two x-intercepts. We don't know what they are so far, but at least we got this much. Why did I know it opens upwards? Well, its a value here and here are positive, so it opens upwards. For these two, the a values are negative, so they open downwards. So I've sketched for this 2a pretty horribly, 3a with a minimal detail on what these parabolas look like. Right, this one, it becomes more of that practice of using this formula, negative 2 over a equals equation x equals this for axes of symmetry. So there's the a value, there's the c value, b here equals 0. So as we plug it into this formula, x equals negative 0 all over 2 times 1 gives us 0 over 2, which gives us 0. X equals 0, axes of symmetry. The coordinates of our vertex, just like from before, we put in 0 into this equation, y equals 0 squared minus 2, which gives us negative 2. Vertex is at 0, negative 2. Happens to also be its y-intercept. Because we see that the a value is positive, this one is going to open upwards. Sketch. So your vertex is going to be a minimum. Okay, so these are much shorter problems. The sketch of the graph from before helps us with these, but notice that sketching graphs with tables, it's really time consuming. So for here, a equals 1, b equals negative 2, c equals negative 3. Though we don't use c right now, later we will when we go over the quadratic equation. Negative b over 2a. We get negative 2 on the top. 2 over 2 gives us 1. X equals 1. Axes of symmetry. Y equals 1 squared minus 2 times 1 minus 3. That gives us 1 minus 2 minus 3. Gives us a grand total of negative 4. Vertex is at 1 comma negative 4. The looks of the graph, when I sketch it, 1, negative 4, it's like here. It's going to open upwards, so minimum. Two more practice problems. Oh shoot. So I'm taking a look at the time. These ones will be quick. So negative 2 over this. X equals all this. Negative 2 all over negative 1. Negative 2 over 2, positive 1. Y equals 1. That plus 2 plus 1. 2. Vertex is at 1 comma 2. Now, since you have your a value being negative, it's going to look like this. It's going to open downwards. This one's going to be a maximum. This one also, it's going to open downwards. -2 over a, -4 over -2 gives us +2. Vertex is at 2, 3. Then we're going to see that this one is also a maximum. Two more problems. Notice here, you just have an A term. No B or C. So for this problem, -b over 2a gives you 0. Y is going to give you 0. Vertex is at 0, 0. It's going to be a minimum. Sketch the graph. Looks like this. Opens upwards. Axes of symmetry is at x equals 0. Last problem. Now we actually have more interesting A, B, and C values. Axes of symmetry equation looks like that. -12 over 2 times 4. We get a fraction. -3 over 2. Y equals, oh boy, this complicated thing. So we get 4 times 9 over 4 plus 36 over this, -18 plus 9, 9 minus 18 plus 9, great, equals 0. So vertex is at -3/2 and 2. We see that A value is positive, so your sketch would look like this. It's a minimum. Alright, that was it. Last set of problems, we estimate its roots. Roots just means x-intercepts. Okay. It also means solutions. Sometimes there's another name, they're called zeros. Right, that's less common. So for this one, as we zoom in, you notice it's right here and here. If you pay attention to the scale, there's 1, 2, 3, and 4. So maybe we'll call this one 1.5. We'll call this one -4, -3, -2, -1, 0.5, about. That's it. So there's your standard parabola. Quadratic has 2 roots. Sometimes they have just one root, like it does here. 1. Okay. That's it. From this equation. That's if we have the graph already. Notice how much quicker it is. The first couple problems, it takes a while to graph it. So you can just put it into Desmos or your graphing calculator if you own one. Last one, over here, notice it never crosses the x-intercept. So this one has no roots. That can happen sometimes. And most real-world situations, you won't have this case. You'll likely have one of these two cases. So going back to the very beginning, we reviewed factoring for one of them, realized that we can't do it all the time. We went over negative b over 2a for the x-axis of symmetry, or the x-coordinate of your vertex. Okay, remember that. Then we sketched graphs based on that information, and then we located roots of a quadratic given the graph.